months to bring this whole project to fruition for you guys. Can you give us a countdown?
No, just go.
Okay.
Just fine.
Okay. Good morning. Welcome to Ridgecrest Robotics and welcome to Ridgecrest Space and Robotics Team's live balloon launch. I'm Emma, your flight director.
And I'm Leland, her host. Your other host.
We'll be your anchors for this morning. We've been working really hard these past few months to bring this whole project to fruition, and we have some pretty interesting projects to go over that's been involving the whole launch process. You want to walk us through some of the timestamps?
So, first I'll be interviewing the recovery team director, Landon, and then we will be cutting the camera to the launch site, where we will be explaining what's going on over there.
We'll be doing check-ins with our Featherlight tracker about every 10,000 feet, and that should be about every 10 minutes, right?
Yes.
Yeah, the ascension is 1,000 feet every 10 minutes. Every 1 minute, yeah. You want to go over the Gatorade thing?
And attached to our balloon are 6 experiments. We have gusher gummy, marshmallow, popcorn kernels, gallium, rubber bands, and plastic filaments. We'll be discussing more on that later.
A younger RCA student class provided the gusher for one of our experiments, and we'll be interviewing them. We'll be talking pretty much about everything, I think, involving the whole process of putting this all together. And we're really excited about it.
We'll be explaining the flight tracker attached to the underneath the balloon, the spot GPS, how the balloon will burst, the parachute, how that will deploy. We'll be going through everything.
Yeah. I think we have our recovery team manager ready to interview, right?
Mm-hmm.
You want to go to them?
Okay, Landon.
Landon, come on.
Everybody, this is Landon. Everybody, this is Landon, the recovery team director. So, Landon, can you tell me what does the recovery team do other than the obvious?
Well, the recovery team is, as it is pretty obvious, the answer is we're going to be tracking the balloon, and we are going to essentially find it wherever it is, whether it's in a tree, pond, marsh, power line.
So, I heard that the vehicle you'll be riding in has a name.
Yes, it is called Gator Bait. The guy on top of this, he was emailing everyone about my job and how we were going into a gator-infested swamp. So I'm like, I'm gonna grab that and I'm going to turn it into something funny. So the vehicle's named Gator Bait.
So, who are the people you're looking over? Who will be with you?
The people being with me will be McKenna, which is essentially the cameraman in the vehicle. Luke Goldsby, our communications director. Ty, our recovery specialist. So he's gonna be the one grabbing the balloon and such. And then me, the director over all of it. And then my dad driving. I'm not old enough yet. And then equipment vehicle.
Right. And so, what is the equipment that you're taking in the vehicle?
So, we can't really chop down any trees if it lands in one, so we took a ladder and a 18-foot long pole with a net on the end, so that way we can probably hook it out of water or a tree.
So, like, just running through some of the circumstances, what would you do if it lands on someone's property?
If it lands on someone's property, we would obviously ask the owner if we can go onto their property. If we can't ask the owner, we'll ask the nearest house, and if they're okay with it and they know the owner will be fine with it, then we'll just go into that field and grab it.
What if it does land in a body of water? Like, will the balloon float for an amount of time?
Yes, it will float for an amount of time. The balloon has burst at this point, but the parachute and the capsules that the experiments are in, they will float for about an hour.
So, what if it lands in something like the road or an electrical wire?
If it lands in a road, I'm assuming we're just gonna pull over really quick, like onto the side of the street and grab it. If it does land on a power line, the only thing we're legally able to do is to call the power company and ask them to climb up and go get it.
So, Ty, the recovery specialist, he will be the one grabbing the balloon?
Yes, most likely.
All right. Thank you.
All right, why don't we cut to our flight tracker and see how that's doing? All right, we can see that it's predicted to go southeast.
There it is.
There we go. Those are the forecast results. They can change rapidly depending on the weather and the forecasts.
Yes, because most of this weather is really just the prediction.
Yeah.
Starts there.
All right, you can see there the rapid ascent.
That's not rapid. Are we live? above the yellow point is the supposed site of where the balloon's going to burst.
And then you can see from there where it will descend, and the red point is where we're hoping it's going to land, but there's really no telling at the end of the day.
The radius is the best guess, the big circle around the red point.
And that's where our recovery team will be ready to go.
As you can see, the balloon falls faster than it rises because gravity.
All right, soon we'll be checking in with our launch site manager and how we're going to be filling with the balloon. We're really thankful for our helium sponsor, Airgas.
Mm-hmm.
You want to talk a little bit about that?
So, Airgas, as the name implies, they sell gases that they can extract from the air, or like helium, which is, though there are trace amounts of it in the air, it's, I can't remember, coming from natural gases,
Yeah, it's not
like the decay of
it's not
natural
reusable,
gases,
yeah.
sell helium. And they also sell it to SpaceX and hospitals. Thank you, Airgas.
Thank you. All right, moving on. Why don't we cut to Sean, see how he's doing?
Can we cut to Sean?
Can we cut to Sean? Oh, we do. I believe we're calling him. We're getting there. All right, in the meantime, I have some jokes for you, Leland.
Yay.
Why didn't the sun go to college?
Why?
Because it already had 1,000,000 degrees. Come on, not even a laugh. Come on.
No, not even
Really?
a laugh.
Okay. Okay.
You gotta chuckle.
Okay. So I've been reading a book about
Dude,
anti-gravity.
Yes, mute.
Did it just float away?
It's impossible to put down. All right, I think we've got our launch site manager here now. No? No, we don't. Okay. You're in luck. What's Saturn's favorite movie?
I don't know.
Lord of the Rings. Oh, there we can see them.
Can they? No, they can't. You can't.
Well, we
They
can
can't.
see. Okay, there they are. Yeah. You can see them there on the tarp so that we don't damage the balloon. They're wearing gloves so that the oils from their hands don't damage the latex and make it more susceptible to bursting. It could be a really precarious process to set up the whole weather balloon. And I'm sure we'll hear more about that from our manager, Sean. He's in charge of all of it. Yeah, you can see them there. I think that's one of the experiments that they're handling. Is that what that is? No.
Could be the gallium.
Could be the gallium.
Because gallium it will stain your skin worse than a Sharpie.
Do we have any audio from the launch site? No? You can see the helium tank there.
That balloon looks really small.
It won't for long. 80
And
cubic feet of helium is going to be right in there.
though that balloon looks small, it's definitely going to be bigger once all the helium's inside of it.
All right, you can see them there putting the helium in the balloon. They just started.
The kid at the helium tank, that is Alex, our helium manager. We'll be talking more to him about what this job actually feels like and
What all of
I'll
his
say
duties
about
entail.
an hour. It's just so peaceful watching it blow up.
Yeah, 80 cubic feet will be 80 cubic feet of helium will be filling that balloon, and hopefully it'll rise to about 70 to 80,000 feet and be bursting somewhere around there.
So, Addie will be tracking Addie, who's tracking the featherlight,
Mm-hmm.
he will be alerting us every 10,000 feet, which would be every 10 minutes.
Yeah, I believe we'll be interviewing him a little bit later.
Hey.
All right, we've got Sean here right now.
Hello. Right now we are just filling up the balloon until it gets to be just about floating. Then we can turn all the different mechanics on.
Looks just like it's floating.
So, Sean, tell us about how you're filling the balloon. What are some of the precautions that you're taking?
Right now we have a tarp out. We have gloves on so that the oils on our fingers don't get on the balloon, and that'll cause the balloon to pop a lot sooner than we need it to.
There's no oils on the tarp, right?
Why don't you tell us about some of the equipment that you're using?
Well, the equipment that we're using to fill up the balloon is with a helium tank. We have it at 75% power right now. We need to start hanging on to that. And then we have a spot tracker. It'll track our position. Sorry, it's really loud. And we have another GPS tracker that will spot our height.
So, the parachute that's right under the balloon, how is it going to deploy?
Well, whenever it senses a sudden drop in altitude, then it will automatically deploy. Because we have it tied in a certain way, it'll allow it to deploy.
Just turn it forward.
How high are you hoping the balloon goes?
I'm hoping a bit higher than 80,000 feet. I'm praying that it goes higher than 500, honestly.
What are some of the challenges that you've faced as launch site manager?
Honestly, I haven't faced too many challenges. It's been pretty smooth sailing, but don't let me jinx that. The biggest problem is trying to find what different experiments to send up, and also trying to connect all the things together was kind of an issue too.
How are the experiments held?
They are held in this wooden compartment that has holes in it, and right now they're in test tubes with lids that hold on in the wooden compartments. There are also orange wires that are covering them to help keep them in place.
What's the picture of?
The picture is of us, of all of us. We're hoping that will get sent up to space so we can all go to space.
And the camera on the end, you have to make sure that everything's on, right?
Yep. We're going to turn everything on whenever we're finished filling up the balloon.
Alright.
What's one of your favorite things about this job? Was it your first choice?
It was my first choice, actually, and I'm really happy that I got it. My favorite thing about this job is being able to actually be a leader, because previously, in previous years, whenever we were doing the robotics, I wasn't actually a leader. I've been on the team for 6 years now.
6 years. Wow.
6 years.
What all have you learned about being a leader over those 6 years?
I've learned how to communicate with people much better than I used to be.
Yeah.
Been able to actually speak with people in a competent manner, and I've been able to actually calm down around people, because I used to be really nervous to talk to people, and now I'm a lot less.
So you're a senior this year. It's your last year on the team. If you could give advice to someone who's going into their first year of being on the team, what would that be?
I would say don't go into it being nervous, because I'm sure with how I've helped with some of these people who will be continuing our legacy, I'm hoping that these people will be able to help us. And I'm very sure that they will. I'm very sure that they will be able to be very good leaders.
So, Sean, can you tell us what the balloon looks like from top to bottom?
Okay, so first of all, we have the balloon, we have the parachute, then we have our spot tracker in the blue bag right here, and then we have our experiments, which is in the wooden piece with the camera, and then we have our GPS tracker.
Where is the site right now?
We are at Mount Gilead Church. We are just in the field right next to it. I found out that it's pretty much the perfect place to do this. It's very clear out here.
All right, we can see that balloon rapidly filling. Sean, we wish you the best.
Thank you.
All right, that wraps up our interview with our launch site coordinator. That was really interesting to see. Yep, that'll be 80 cubic feet of helium in that balloon. That's a whole
That's
lot.
a pretty big balloon. Probably make your voice sound pretty squeaky.
All right, while we're waiting on our go, no-go sequence and for that balloon to fill up,
Air Force Base 10 days.
I think I've got one or two left. All right, I've got one left, actually. Why does nobody trust the moon?
Why?
'Cause it's got a dark side. I love hearing them laugh in Mission Control. Okay. Yeah, we're about, yep. Our go, no-go sequence should be whenever we're getting that balloon filled up. That's pretty much all we're waiting on right now. And while we're waiting on that, what have you gotten from this experience so far?
Well, I've learned that being a reporter is definitely something new that I haven't done.
Yeah, new, stressful. I think both of us have had to really get comfortable in front of a camera, and it's been quite the experience so far. This is my first year. And
Ditto.
yeah, this is both of our first years, and they gave us the job of reporters. Can they see? Can they see the launch site? There we are. They should be wrapping things up right now, getting ready to release it. Unless something's wrong.
Don't say that.
Which there isn't. It's gonna be great. It's gonna go fine.
Sarcasm dripping from her voice.
I ran out of dad jokes.
You can always pull out that other one as a last resort.
You can see just how much that balloon has expanded in such a short period of time.
Even though the balloon is all filled up and pretty high off the ground, they still have to make sure that they don't touch it, because the oil in their hands could weaken the rubber.
Like Sean said.
Like Sean said, it'll cause it to pop early, which we don't want, because then it won't be on the edge of space.
Thank you for being patient with us while we wait on the balloon. Why don't we check in on our flight tracker, our flight predictor,
Flight predictor.
both of them. There it is. All right, so it's pretty much the same as before. Luckily, we aren't having any tumultuous weather today.
It's kind of cool just watching how it can go up and then come back down in such a short amount of time.
Yeah. All right, you can see that balloon getting really big. Well, you should be. There it is.
They tied off the balloon, and
Looking,
as far as we can just see from here, everything looks like it's ready to go, but got about 6 more minutes to launch.
looks like they've got some wind there. And you can see them there in the back of Mount Gilead Church. And like Sean was saying, it's really important to pick the right launch site. And we'll hear more from our launch site coordinator a little down the road. We had several sites to pick from, and it was really important that they weren't near bodies of water or, you know, near massive trees or things like that. So it's easier for our recovery team to get the balloon back to us so we can look at the experiments and see all the data from our flight.
And also, it's important that they're not near airfields.
Mm-hmm. Definitely.
Because even though that it's 2 pounds and a plane hitting it won't feel much of anything,
You could
They
still
still gotta
shock the
be-
pilot.
still got to know what's happening.
Mm-hmm. Looks like we've got 4 minutes to launch.
4 minutes to lunch?
I wish. Speaking of lunch food, thank you to Danielle for those donuts this morning. They were wonderful. You can see Mission Control working tirelessly to make this flight go smoothly.
Two minutes to launch.
Hey, Leland,
What?
how do you keep your pants up in space?
An asteroid belt.
No, you got it! Okay.
That was
Why did the
hard.
restaurant on the moon fail? It had no atmosphere. All right, I believe we're ready for our go, no-go sequence. Thank you for being patient with us.
Commencing our go, no-go sequence. Spot GPS.
Go.
We have a go from Spot GPS. Camera.
Go.
We have a go from the camera. Launch site.
Go.
We have go from launch site. Flight predictor.
Go.
We have go for launch. Featherlight.
Go.
We are go for launch.
All right.
Right now. I'm about to do it.
Go ahead and let it up. Let it up. Don't rope her, or you're supposed to be wearing gloves. Where's our camera?
All right, keep your eyes on that balloon. I believe they're about to let it go.
Starting countdown for launch. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
There it goes.
Be free.
We have liftoff.
All right. Well, that went smoothly. You can see it up there. Not sure how long we'll have visibility from the ground on our balloon, but we will have the data and where it's going. That'll be with Addie, and we'll be checking with him about every 10 minutes. I already said that. It's fine. All right, I think we're about to check in with our Spot GPS. All right, you can see it there. We'll also be looking at tracker updates with our launch site manager, Sean, every 5 minutes. It only updates every 5 minutes, so about
we
as
won't-
often as that happens.
5 minutes. We won't have spot GPS yet. But let's talk about the experiments.
Yeah.
There is. So first off, we have in one of those capsules in the experiment package a small triangle of gallium, which is a metal, I think, that if it gets on any other type of metal like iron, steel, stainless steel,
It pretty much
It-
corrodes it.
makes it brittle enough to break it with your bare hands. And it's not toxic. Not saying that you should put it in your mouth, but it will really stain your skin if you hold it.
Another good reason to wear gloves at the launch site. All right, next up we have our RCS student. Their experiment. It was a gusher. We're going to see how it reacts to the changes in pressure as it ascends into the atmosphere.
And for another experiment, we also have rubber bands. 3 rubber bands. I've been told. One in the capsule. Another wrapped around the capsule. Another stretched out on top of the capsule to see how the elasticity, their stretchiness, will hold up in the extreme conditions of space.
Well, that'll be really interesting to see if they snap or if they get brittle or if they stay the same. All right, we've got a marshmallow, 2 in there. Lots of really good food. I'm getting hungry. We'll see if, I think personally, it's going to expand because of all the tiny air pockets in there and the change in the pressure. What do you think is going to happen?
I don't know.
Well,
It could blow up.
good thing it's on there so we can find out.
And another experiment are popcorn kernels, because the way that a popcorn kernel pops is the pressure inside is, there's more pushing out on the inside than on the outside, pushing in. So it explodes into a popcorn kernel. To a popcorn.
Yeah.
And then also from Robotics, the
3D printed filaments, we'll be setting those up as well for future flights, actually, to see how well they hold up and if they can be a material that we use in the future for, things in general, just building the schematics.
and we'd like to thank Robotics for their sponsorship and for taking the time to make the rockets that are right behind us.
That, they can see it, right? They can see it.
They can see it.
That black and gray one right there, that was 3D printed by Mr. Greg and his team. Pretty cool, right?
I want a 3D printer. They also sell robotic lawnmowers, in case you're interested. I know
All right, we've got our flight tracker up there. Again, we only get updates from this every 5 minutes and while it's in motion. So if something goes wrong and it's not in motion, no updates. Hey, Leland.
What?
Why did the Earth make fun of the moon?
Why?
Because it has no life.
That's mean.
Okay. What did the astronaut do after he crashed into the moon? Don't look. Just guess.
I don't know.
He apologized. Get it? Because the Apollo missions. This is so bad. All right. You can see our forecast results there. They're looking pretty much the same as they were. I don't think anything significant has changed.
So, Emma, what is your favorite thing about space?
My favorite thing about space,
If you were just to pick one
I
thing.
have to pick one. Oh man.
Actually, pick three.
Okay. One of my most favorite things ever about space is the James Webb Deep Space Telescope. It was recently launched in 2021, I think, after several delays. It's pretty much the sequel to the Hubble, but bigger and better, and it's gonna go further and last longer and take better pictures. I don't know. My second one? Okay, you go. What's one of yours?
Well,
Give me
one
a
thing
second to
that I
think.
dislike about space,
Yeah,
that they decided that Pluto is not a planet.
but it's not a planet.
How is it not a planet?
Because it's so small.
And
And it's just too small. It's just a floating rock out in the Kuiper Belt.
what defines planet?
You tell me, what defines a planet?
Actually, I don't know. But Pluto should be in there with it.
All right, it sounds like we just got our first round of data. So I think we'll cut to that. There it is. Look at that. Our altitude is at about 8,000 feet. Pretty impressive. Almost at 10,000 feet. Not quite, but we're getting there.
The temperature is
The spin.
changed. 84.2 degrees.
Look at that spin rate.
I'm pretty sure that's Fahrenheit. I'm not so sure.
Degrees. Yeah, that should. It'd be really bad if that was
Oh yeah,
Celsius.
if it was Celsius, that'd be.
Turbulence. We don't have any turbulence right now. The battery is looking good.
Pressure is around the same as down here,
Yeah.
I think. Your
Can
ears
we
were hot.
switch to satellite on that? Get a satellite view? Or do we just have the map view? I hear a lot of talking. It's okay if we can't.
I still think Pluto's a
You
planet.
can keep an eye on that altitude. It's slowly rising. Oh, I was asking if we could get a satellite view on the map. There we go. That's much nicer to look at.
Just outside the circle, and a bit
Yep.
to the left.
You can see it's pretty much right where we launched at, so it's not changing too much in direction, which means there's not a lot of wind speed, which is really good.
No, it moved.
Yep. I can hear from Mission Control talking that they're right on track. It's looking good.
Hopefully.
Kind of eavesdropping there.
All right. I say we go back to the questions. You said your favorite thing. I said my least favorite thing. Now, what's your least favorite thing?
My least favorite thing? I don't know if I could pick one about space. I think I like everything about space.
Well, the fact that you can't breathe is probably pretty big.
I mean, it kind of makes things interesting
Slight
though.
problem.
Yeah.
Hold your breath. You'll be fine.
Actually, you won't.
I know.
All right.
Not that dumb.
So how much helium was required for the launch?
I believe it was 80 cubic feet of helium that needed to be in the balloon.
So big
But
old bunch.
the thing is, if you don't put enough helium in the balloon, then the pressure, it will make it go higher than what we want it to go. But if we put too much helium in the balloon, then it will pop lower because it's all about the air pressure around it.
Yeah. No matter what, it will pop because the pressure is changing so much.
It's still gonna pop.
Yeah.
But the more accurate we are, the more accurate we know where it's gonna land. So there is most definitely about the launch site and the airmen. We need to alert the airmen of that we're sending a balloon into the air so that they can try not to hit it.
Officially, that's called a NOTAM, or Notice to Airmen. Basically alerting any pilots in the area, or municipal airports around the area of our launch site, hey, there's gonna be a pretty big balloon going up. Heads up, don't fly that way. We'll be talking more about that a little later on. Yeah.
Actually, you can explain the NOTAM process now.
All right, you can see it steadily going. Our altitude has increased to about 12,000 feet, just a little bit over. You can see mission control hard at work. While they're doing that, a little bit more about the NOTAM process. Yeah, it was given by the flight operation personnel, or our flight predictor, Cooper. I think we'll be interviewing him later. Or not. The date and the time of the operation is a really specific thing that needs to be given at least 24 hours in advance to the FAA. So pretty official stuff, don't you think? Yeah.
We need to tell them that how heavy it's gonna be, how high we think it's going to go, its density, surface area. We basically need to tell them every little thing about the balloon.
And it was pretty difficult to work out the multiple launch site options. We didn't choose it until pretty recently, I don't think. And to give a NOTAM, you have to have a definite launch site. We'll talk to Cooper more about that later.
I think we're interviewing Cooper there.
I think we're giving him a call. I don't know.
Alright, so back to the question. My favorite thing about space might be the International Space Station.
That is pretty cool.
Not the dry food at the space station, but the space station itself.
Have you ever had one of those freeze-dried ice cream bars?
Yes.
They're pretty
Never
good.
again.
Never again?
Never
They're delicious. What are you talking
No,
about?
they're not.
You're crazy.
I hold to my opinion, you hold to yours.
He has no taste.
Or you have the wrong taste. I should taste myself.
Hey, Leland.
What? I already know where this is going.
Why did the astronaut get fired?
Wait, I can think of this one.
Don't look at the answers.
I'm not looking at the answers, I'm thinking. I don't know.
He was spacing out at work. Oh.
Well, that's how I feel like when I'm doing school.
I'm hilarious, aren't I?
Hilarious.
What's our time?
speculative.
9:48. All right.
about Alpha?
I think we should be having our RCA student interview any minute now.
Yeah, even have one.
I'm gonna go see about that.
And wow, she goes to see the interviewee. I like to sponsor Alfab, which is metal fabricators. They work with the metal. They work with metal, and and they can also sell some of their stuff and help work with the U.S. Army and the Coast Guard.
Interesting stuff. Interview.
So we just got news that the RCA student interview couldn't happen. So instead of waiting for him like we said we would, him or her, like we said we would, we'll be talking about the Gusher experiment.
So what do you think is going to happen to it? Do
I
you think it'll
think it will
freeze?
explode.
I think so too. The changes in pressure, I think it'll be similar to the marshmallow, but gushier. I mean, it's got liquid inside. It's going to go everywhere inside the capsule.
It's called the Gusher. You said you think it's gonna be like a marshmallow?
I don't think it'll
But
be
gushier?
exactly like a marshmallow.
Yes,
It's just,
it's gonna be gushier.
I think it'll be a messier cleanup for sure. Unless,
That's why I'm not gonna clean it up.
I mean, it's not our job, thankfully.
Just to be clear, by Gusher we're talking about the gummies with the gel on the inside.
Yeah. It's a gummy candy with a sugary, corn syrupy filling. Pretty
Just
good.
explain it like that. Make me feel bad.
Okay.
If you could be an astronaut, but you had to go through all the training, would you?
Yeah, the training's the fun part. What are you talking about?
Is the training the fun part?
Yeah. I mean, they get to do mock flights. They get to scuba dive underwater so that they can feel like they're under
Just be a
zero
scuba diver.
gravity. Scuba diving's cool.
But all the things you have to do to be an astronaut, you have to prepare yourself for literally the gorilla sitting on your chest as you're going up.
Yeah. You need to be really fit to go to space. You need certain
Deep breath.
degrees. Fun fact, a majority of astronauts have gone to the Naval Academy. So
What?
if you want to be an astronaut, look into the Naval Academy. They're pretty good. All right. I think we will interview Nathan about the site selection.
Please,
Or-
Jason back.
Yeah.
Right, you gotta go find Nathan.
Okay.
You gotta do it, fella.
Okay. All right. While Leland is tracking down our our next interviewee, just be patient with us. We're working on it. I promise. All right. He has not returned yet, unfortunately. But as soon as he does, he'll be right in the hot seat. You know what? Why don't we check in with our featherlight? It should be about 20,000 feet, right? 16,000. Okay. Okay, we're getting there. Slowly but surely. You can see it's about 14 miles per hour. It was only 7 miles per hour last time we checked in, so it's steadily increasing speed.
Alright, give me a joke.
Hey, Leland.
What?
Why did the restaurant on the moon
You
close?
already said this one.
Oh, I already said that one? No!
Because it didn't have any atmosphere.
Wait, give me a second. I'm trying to find one.
All right, one.
All right, I got one.
What?
What do you call a lazy person in space?
What do you call a lazy person in space?
Come on.
I don't know. What do you call a lazy person in space?
Procrastinaut. Not even a laugh, not even a small one.
You're fired.
Fired?
Just kidding.
Can't be fired from something I'm not even getting paid to do.
Yeah, because we still have to talk about why Pluto should be a planet.
I just don't think it's important.
It's very important.
It's a.
Why would it not? Why
it's
would?
tiny.
And they still call it a planet. A dwarf planet, but still
Dwarf.
a planet.
All right, let's go to our GPS tracking manager, Anya. Let's see her screen and look at the Featherlight tracker as well.
It's Featherlight.
There we
Not
go.
GPS.
Lots of complicated numbers I'm sure she knows all about.
And while they're looking at this, if you could live on the moon, would you?
I think it would be pretty dusty.
Like if you had a month-long path to live on the moon.
I mean, if I had to, I guess I would.
Not if you had to, but if you could. I most definitely would.
All right, we're about at 20,000 feet. Thank you, Danielle. There we go, 20,881 feet. The latitude of 31.21 degrees. 21 miles an hour, look at that.
Latitude and longitude.
It's traveled about 2.2 miles. The vertical rate is about 891 feet per minute.
Hitting about 1,000.
Roughly, yeah. You can see the temperature dropping. It's about 60-ish degrees. That sounds nice right now, don't you think? Pressure, 6.8 PSI, 0% humidity.
Is that a point or a south?
Yeah.
It's a point. That's kind of cool.
That is pretty neat.
Thanks, Addie.
Yeah, I believe we'll be interviewing him pretty soon. Yeah.
Just had a question. Okay, I already did it.
All right, while we're sitting here waiting for some more information, we'd like to take the time to thank one of our sponsors, Alfab. They're located in Enterprise. They fabricate metal professionally. So if you need some metal fabrication, go ahead to them. They'll take care of you. They also provide really pretty cool stuff for the military. Pretty neat, right? Oh, we've got our interviewee here. I believe Leland is taken care of. All right, I'll let you introduce him.
All right. Can we get the camera, please? This is Alex, the Helium director, manager. He was the one at the launch site by the helium tank, for obvious reasons. So, tell me, Alex, what is your job?
My job is to fill up the balloon just so that you can carry the package up in space. It's pretty fun, I would say. So, yeah.
How do you tie off the balloon? Like, is there something on the balloon, or?
There is a one-way valve that connects to a clip, and once you're ready, you attach it to the tank so it won't float off as you're filling it up. And once you're ready, you just unclip it and it will float off in space.
Wee. So, how much helium goes in the balloon?
It really depends on how heavy your package is. This year, our package was 2 pounds, so it was 80 cubic feet of helium.
Is there like an equation with that?
Actually, I do not know that. I do not know.
So, how long did it really take to fill it? It looked pretty fast.
It did feel as fast. I felt like it took forever, but it probably took about 5 to 10 minutes.
And I already explained a little bit about this, but why do we have to put this specific amount of helium in the balloon?
Really, so it can lift up the package with enough force, that way it can float.
Like what we learned about air pressure. If there's too much, it's going to explode early.
Yeah.
And if there's not enough, it's going to keep going and get stuck. Another question was, why helium? Like, is there another gas that we can use?
Helium has the smallest molecules of all gases, so we can put more helium in there than other types of gases. Another reason is helium can find leaks. So if you wanted to figure out if there was an actual hole in the balloon, you can fill it up, and if there are any leaks, you can replace the balloon or patch it up.
What are the dangers with the balloon itself? Like, say, I'm pretty sure we've all had a regular balloon that we tied, and we were playing with it, and suddenly it fell on the grass and it popped. Not definitely speaking from experience. So, I'm pretty sure there are similar precautions with this balloon.
Yes, there were a lot of different precautions and things like that. Not really that I can name off the top of my head.
Like, I've heard a few are oils in our hands.
Yeah, so you cannot touch the balloon with your hands because it will actually decrease the balloon's strength. So it will have less elasticity and won't be able to go as high.
Let's see. Like, what if we used, I heard that hydrogen is also lighter than air and floats. What's the difference between those two, if you know off the top of your head?
I really say the size of the air molecules and yeah.
And the high flammability.
Yeah, the high flammability.
That could be a problem.
Yeah. You don't want that to happen.
No.
You definitely don't want that to happen. So.
Thank you, Alex.
Thank you.
All right. That was great.
Note to self, don't light a match near hydrogen. Oh, sweet.
All right. While they were interviewing him, our launch site director, our launch site coordinator came back. Finally. I believe we'll be interviewing him now.
interview him.
So I'm leaving again.
Come. Can we get the camera? There we go. All right, this is Nathan, the launch site coordinator. Launch site coordinator. So, what is your job?
My job basically is picking the right place to launch the balloon, so it would be more convenient for our recovery team.
So, I heard there's 3 other locations in Mount Gilead. Do you know them off the top of your head?
I can name some, I think. We had a place at Carol's Nursery. We know they had a big area that we could possibly do. And then there was another field, I think, in Danzy. And then one near Cottonwood that we could have used. But I think I picked the right choice of choosing Mount Gilead.
And it all goes down to how the weather is, right? The weather, the wind speed.
Yeah, we just need the balloon to be where the recovery team is. Hopefully.
Because we're trying our hardest not to land it in a lake.
Oh yeah.
Or the Gulf of Mexico.
But I think we're going east, and I didn't see any water in that area, so I think we should be good.
And what is the effective airspace? Like the space around an airport?
Like the one that we had near the airport?
Like, is there a certain radius around the airport where nothing can be launched here because it's an airport?
Oh yeah. At Carol's Nursery, they had a airport right by it, and we didn't want to get in the way of like the landings and launching of those airplanes. So that was one of the reasons we didn't pick there.
And as Emma said about the NOTAM, they're supposed to know 24 hours beforehand where you're launching.
Yeah.
So
recently, I've been checking up on the website to see if which place would work the best. So
because you have to find the site, then pick the site. You have to find sites, then pick one of those sites. Then you have to talk to Cooper, the FAA coordinator, and tell him that this is the site to where he gives the NOTAM.
yeah.
Right. Thank you, Nathan.
All right. Thank you.
All right. Thank you again to Nathan, our launch site coordinator.
What was it for him? Have fun,
Or
Gator
in a
Bait.
tree or in a swamp. I believe now we're gonna interview. We're about 30,000 feet. Thank you, Danielle.
Silas.
Yep. We're interviewing our GoPro director and manager, Silas.
It's an Insta360.
All right. Hello, Silas. Welcome. Hey. So you are our high altitude camera operator.
Yes, ma'am.
So just tell me about that.
Well, you see, it's super complex, and if you like, do you want me to tell you about the camera?
Yeah, absolutely.
Okay.
Please.
Okay, so it's like super complex, and if you lay it on anything hard, it'll like shatter the like other camera because it's 2 cameras, and you have to really know how to work it to use it.
So will the footage be edited down into the final cut?
I think so.
Yeah. You can watch that on RBC's YouTube. I would go check it out. Give it a like. So, how will the altitude affect the camera?
I don't know, but we'll get back to you.
Okay, he said that he'll get back to us on that. All right, so tell me why you wanted this position and what's one of your favorite things about it?
Well, I just am pretty good about like technology, and I wanted to film. It just sounded fun.
I guess you'd have to be for this sort of position. What's something cool about the camera?
It's 2 cameras.
It's 2 cameras, really?
Yes.
I actually didn't know that.
Yes, one on each side. That's why you have to like lay it down on something soft.
So is this your first year on the team?
Yes.
What's one thing you've learned so far?
This job isn't easy.
Definitely not. All right. I think that wraps us up for this interview. Thank you very much.
No problem.
Why don't we check back in with our featherlight? An hour? It's gone about 10.5 miles. Wow.
Slowly getting closer to the point where it bursts. Hey Emma, why did Mickey go to space?
Why?
Well, he was looking for the completely true planet, Pluto.
Ha ha.
Quite obviously.
Very funny. You and Pluto. What
Pluto
is it?
is a planet.
I just don't see it.
I see it.
Well, I don't
Like,
think either of
quite
us can
clearly. I
see
see
it.
it.
It's hundreds of thousands of miles away.
Isn't there a telescope or something? Whatchamacallit?
Not one that I can afford.
The piece of gum crossed the road.
They're supposed to be space themed at least.
Why did the piece of gum cross the road?
Oh my goodness. Why?
Because it was stuck to the chicken's foot as it went to the NASA Space Center.
Okay, I see how you tied it in the end there. Very
You're
clever.
welcome.
Okay.
Discover one mystery about space. Like one mystery that's already known, like dark matter or what a black hole actually is. Which one do you choose to actually discover? Be like, hey, I finally figured out what this is.
Okay, so they're on the moon.
Yes.
There's soil under the initial gray dust that you see. And it's like this bright orangey color because it's rich in minerals.
So the
and
moon
I
is
think,
obviously Mars. Got it.
Anyways, that would be what I would pick.
Discovering what it actually is.
Hey, Leland.
Wait, let me have these two on. I want to learn more about black holes.
Black holes.
They're just interesting.
Yeah.
How
I mean,
does-
we know pretty much nothing about them.
Judging by the fact that nothing can get near them without being sucked into an endless vortex.
I think it'd be interesting to
Slight
see
problem.
the inside of it.
Probably dark.
It'd be the last thing you ever did. Okay.
God, I saw the inside of a black hole.
Why don't scientists trust atoms?
Because they always split up.
Because they make up everything. I got some laughs in mission control from that one.
That's a good one.
Okay.
I'm keeping that one.
Okay. Next one. I'm on a roll.
Oh no.
How does the man on the moon cut his hair?
I don't know.
Eclipse it.
They're just so corny, I can't stop laughing.
It's
so
that
bad,
kind
it makes
they're
me
so
laugh.
they're so bad it's good. Okay.
What is actually a true planet?
What?
I still think Pluto's a planet.
Oh my gosh, that wasn't even a joke.
I know. I
Okay,
never said it was.
let's see the time. 10:15. What have we got?
Why did the cow go to space? Don't read it. I know you see it. Don't read it. I really want to do it.
Okay. Okay. Why?
To go to the moon.
Oh.
Alright. I feel like I'm supposed to be explaining something, so I'm just going to explain.
We just have a lot of open time right now.
Yeah, I love open time. It makes me feel like I'm supposed to be doing something.
Yeah.
Alright. What about the balloon burst? Wait, we already
The
talked
balloon
about
burst.
that. Mm-hmm.
Yeah, we're expecting the balloon burst around 80,000 feet. We're hoping, I think, well, I'm hoping that it gets a little higher than that, just because it's cooler the higher it goes.
But if it gets higher, it could get stuck in space.
I don't
Because
know about
the pull
that.
of gravity won't be enough.
I mean, it's gonna pop no matter what once it reaches
Yes.
the edge of the atmosphere.
We can both agree that it's going to pop.
Yeah.
But the balloon burst is really all about air pressure. The less there is, the more likely it will burst. Still looking up space jokes.
Okay. no one needs to know that I'm not thinking of them. The Stratastar website, all that GPS data, we're about
Oh, that's
to
feather light
breach
data.
40,000 feet.
Nearly at 40,000. Almost halfway there. Or over halfway there. I can't remember if it's 70 or 80,000.
These are really bad.
Exactly. What do you call an astronaut that goes bananas?
I already saw it.
I know.
What do you call it? What do you call an astronaut that goes bananas?
An astronaut.
They didn't think that one was funny. I didn't hear them laugh.
Obviously. Fake laughter is worse.
Oh.
So I'm just gonna explain mission control.
Why did the moon skip dinner?
I don't know.
It was already full. Oh.
Gideon.
Gideon will laugh at anything.
So mission control.
We're about at 10:20.
Can we pull up the camera of mission control?
Yeah.
Thank you.
All right,
In
you can see them hard at work there.
In the front, there is Caleb, who is, I think the adult's Mr. Steve.
Oh, you can see them waving. Hi.
But Caleb, who's in the very front, he helps switch all the cameras. So every time I ask for a camera, it's his job to direct the adult to which camera I politely ask for.
All right, our package is running a little north of our predictions. I'm just getting word.
By north, he means that way. And back to mission control. In the middle row, to the very right is...
You have to do the left.
Yes, I have to do that. To the very right is Anea, who is on Spot GPS. Next to Anea is Cooper, the FAA director and flight predictor. And next to the Cooper on the very end is Addie, who is tracking the, give me a second, Featherlight tracker.
There we go.
Who's in the back?
What's this? Okay, I can work with this.
Sorry, that was funny.
Thank you for the material, Danielle. How do you organize a space party?
You plan it.
Oh, come on, you ruined it.
I already read it on there.
Cheater.
Haha.
Okay. Okay.
Try me.
Oh, these are so bad. I love them. What's an astronaut's favorite part of a computer?
I don't know.
The space bar.
Of course. I just think too hard about it.
Okay. You know, I thought I had another joke, but my head's just full of space right now. Oh, no one laughed. Come on.
That one was really bad.
That was a really bad one.
That wins the bad joke reward.
Okay. Where are we at? 1021?
I think we're at 40,000 feet. Yep.
About 42,000. Look at that. Check back in with StreamYard.
Should be seeing the. I'm pretty sure you've heard about it, but the strange dip in the strange rise in temperature in the atmosphere. Like it lowers as you go up, and then you hit a point, and it gets higher.
Yeah.
But then it goes back.
I think that's
again.
the edge of the troposphere. Where the weather sits. The fun
I can't
stuff.
remember where all the spheres are.
You have to do Newton.
I got right.
Why don't we check in with Addie, our Featherlight tracking manager?
Talk about the data, what you see here.
All right, we're about at 45,000 feet in the air. Ooh, 61 miles an hour. Look at that.
Slowly getting faster. Or wait.
We've almost gone about 20 miles, and the vertical rate, almost
feet per minute.
900 feet per minute. Wow. The temperature, oh wow, we've reached 0 degrees.
Now we're in -0 degrees.
No humidity. Oh, that sounds so nice. This weather lately. Spin rate,
That
pretty
number's
much
too
next
big
to
for me
0.
say.
No turbulence.
Let's call it 7. And I'm pretty sure the battery is
Can we zoom out and see the whole? There we go. Look at that.
It's definitely
It's definitely
yeah, it's
traveling.
definitely a bit north than the flight
You can
prediction.
see it's going a little more northeast than we thought it would, but that's okay. It's okay. Our recovery team is on it, and we've got everything under control.
Ooh, temperature versus altitude.
I need to do the new thing. Help me. Series as well as water coolers. And Leland, I don't know about you, but in the summer there's nothing better than some nice cold water straight from the faucet.
Straight from the. Wait, what is a water cooler?
You've never
Like
drank
a
from a hose
cooler?
before? Like for this.
Define water
Thank
cooler.
you, Newton Distributing Company, for your generous contributions to our efforts. So it looks like our balloon camera will last about an hour. Yeah.
And the featherlight does not track humidity.
Yeah.
So that 0
Oh.
was not what you thought it was.
Wishful thinking on
I'm
my part.
sorry.
Yeah. All right. I think now we're going to be interviewing Addie, our featherlight tracking manager.
And they'll have the feather light on this, won't?
Mm-hmm.
Yeah.
There we are.
There we are.
Okay, cool. So this is Addie. He is our featherlight tracking manager. So just tell us a little bit about your job.
So as the featherlight device, you will see the screen over here, and you'll see the temperature, height, and all of that. So as my job as the data logger, I take that data, collect it, and just log it so we know the environment of our experiments.
Very cool. So what will the data that you're recording be used for ultimately?
So it's going to be used for the experiment. So we will know the environment they're in, so we will know what the conditions they were under to see what happens. So if something happens, we can see, okay, this is the XYZ environment that they were in. And that's the main purpose of this.
So explain to us about the 10-minute check-ins.
So roughly 10 minutes, you'll see we'll hit about 10,000 feet every 10 minutes. So the check-ins is meant to be at every 10,000 feet interval. Currently, we're at about 46,000 feet, and it will periodically go up about 10 minutes. And you can see, the vertical right there is about how fast it's going, and each minute is roughly with that.
Good to know. So what's some viewer data that they can look for?
So
something that anyone can track.
The main thing I would say is the main things: the altitude, temperature, and pressure. Those are the most interesting things, and you can actually see that on the graphs, how they're steadily changing.
Right, so how many years have you been on the robotics and space team?
Well, this is my 4th year, so I've been around a fair amount of time. I've earned a name.
What's one thing you've learned?
Cooperation. It takes a lot of teamwork to be in a team. We work as a team.
For sure.
If one person doesn't do the job, the whole team will suffer from it. Everyone has a part, and everyone's part is really important.
Exactly. And lastly, what's your favorite thing about your job?
Honestly, just the fact that I have all that data right in front of me, and I can look at what I want to look at right on that, and just periodically change it and to see all the information as it changes.
The 10-minute check-ins are pretty fun too, I think.
Oh yeah. Definitely. Definitely.
All right, well, thank you very much for your input. I think that concludes our interview.
I say we take a 2-minute break.
Okay, we're a little behind. talk
see the
about it?
shirt.
I can stand up. I can like, don't fall over. I can
Don't
like,
fall over.
I can like show my back, and you can, if you want. Okay.
It's Psalm 19:1.
We need to
It's the
fill some
Bible.
time. See if
You
we can
explain
get
the shirt. I'll find a bit.
what? Get a pin or something. See if you can get a pin. They're pretty nice, don't you think?
Front, back.
So our design manager and coordinator, McKenna, I think we'll be interviewing her soon, right?
No.
No?
It's really just going to be a
We
chicken
won't be
and
interviewing her soon. That's okay, we can talk about it. You can see here we've got Ridgecrest Robotics and Space Team and our Bible verse right there. Yeah.
Psalm 19:1.
Psalm 19:1. It's pretty important to our team. The heavens declare the glory of the Lord. Yeah. We've got the balloon there with the cross in the middle.
Oh, that's a balloon. It looks like a light bulb.
It does, doesn't it? I can't unsee it now. You ruined
Oops.
it. All right. You could, yeah. Okay, why don't we look back at our feather light? I like looking at that. 50,000 feet. Woo!
I want it to be 8,000 so it could burst. I wish we could get a video of the burst. Oh, the pin.
Oh, the pin! These are nice. This is, all right, can I get the camera again? Pretty please. Thank you. This is actually the first time I've seen it so far, but it's an enamel pin. Hold on. I'm gonna get up close and personal so you guys can see it.
It's not going to focus.
It's not gonna focus?
Yeah, it's not
Oh.
going to focus. Go back.
Oh man. Well, you can purchase one for yourself, contribute to our team,
Wait, we can.
and we can purchase them, right? Anyways, it's the same design as our t-shirt. Why don't you stand up again, turn around,
It's not the
please?
same design as our t-shirt, though.
It's similar.
Is it, though?
Yeah, on the balloon? It's got the emblem.
Except that balloon looks like a balloon, not a light bulb.
Yeah. This is our Alpha Flight pin, the first ever flight we've done. It's got nice little colors.
That you can definitely see.
I'm trying my best here. Anyways, yeah. Pretty cool stuff. Get you some swag. Yeah.
I don't think we're selling them.
Are we not selling them? Why would we sell them? They're so cool. Okay. We're at 10:32.
The sky's not the limit.
I think you're supposed to explain the balloon burst right now.
Explain the what now?
The balloon burst.
Actually, we're trying to get McKenna because we kind of flip things over.
Oh, yeah. Where is McKenna? Here. He might be successful. I don't know. So, give us a little rundown of what you've done so far.
It's going good. We are in Georgia State. We're on Route 91 right now.
Are you having any trouble so far with tracking?
Not really. We're just driving to the estimate of where it is going to land.
Let's cough into it. So, like, are you at the spot where you think it's gonna land? Or are you close?
Not yet. We'll be there in 7.6 miles.
All right, so they're rapidly getting there.
Yeah.
And you and Landon are following what Anea is saying, right?
Yes.
Where the spot GPS is.
And you get updates from that every 5 minutes, correct?
Yes.
All right, well, thank you, McKenna. We'll be sure to check back in with you soon.
Okie dokie.
Thank you, McKenna.
You're welcome.
Hey, Leland.
What?
What does the moon put on her toast?
I can think about this one. No, I can't. What?
Space Jam.
See, even the people at Mission Control know that it's going to be a joke when you start with Hey Leland. Because they instantly
I think they're just giving me pity laughs now. That almost hurts more than not laughing at all. Okay.
My exasperated sigh is actually a pretty big laugh.
They look a little stressed out there. I hope they're doing okay. Hi.
How does an astronaut call his ex from space?
What?
By using SpaceX.
Ha ha. Very, very, very funny.
Oh, I don't even get pity laughs. This is sad.
Let's see. What's the moon's favorite bagel?
What's the moon's
Don't look
favorite
at it.
bagel? Oh, I didn't read it. What's the moon's favorite bagel?
Yeah.
I don't know. What is the moon's favorite bagel?
Cinnamon raisin.
Cinnamon raisin?
Mm-hmm.
It's almost as bad as the cow who
Get
jumped
some-
over the moon.
Put some cream cheese on there.
Cream moon cheese.
Alright, you want to Let's look back at our feather light.
6,000.
60,000.
No, 60,000. Not 6,000, 60,000. I'm reading these.
Aw. Okay.
I'm kidding. How long do you think it will be before Saturn gets married? I mean, it always has a ring.
Oh, that was a good one.
What's your favorite planet?
What was that?
What's your favorite planet?
My favorite planet?
Like, not just limiting to the solar system, but if you know the numbers and letters of
I know it's
X007, what
I know it's kind of overused, but it's gotta be Mars. It's just cool.
I like between two planets, Earth,
Classic.
because we can all survive on this without really needing any help, and Pluto.
How many times are we gonna circle back to Pluto?
As many times as I can. I will find a segue.
Okay.
Do you know how long the camera will last on the balloon?
I earlier we got word that it shouldn't last more than an hour. So we'll only have an hour's worth of footage, which should capture
It
most
should
of the
get it
ascent,
up there.
but not a lot of the descent.
It should get it up there.
All right.
Speaking of descent, as you lay your head down on the pillow, I really hope it's a mattress from Mr. Mattress.
We'd like to take this time to thank another one of our generous sponsors, Mr. Mattress, for providing us with the means to buy all the parts necessary. They're located in Dothan. You know, I really needed a good night's rest last night. I got some good rest on a Mr. Mattress.
From Mr. Mattress.
From Mr. Mattress. Right.
And there's another sponsor called Rent Ready.
Oh, tell me about that.
I couldn't look into the website as much as I really wanted to.
Well,
I
it
believe
sounds
they
like
rent out
they're
objects too.
ready to rent. Thank you,
How
Rent
many
Ready,
corny
for your
jokes can
generous contribution.
How many corny jokes can we make as compromise?
Okay.
Again.
You want to start?
There you go.
Why don't we check back in with our flight tracker so we can have that information up there?
Featherlight?
Sorry. Sorry, that's my bad. Featherlight. So about roughly 20,000 more feet to go before we're expecting our balloon burst. The air pressure, that really affects the balloon and its bursting capacity.
Obviously.
Obviously. Yeah.
The pressure inside the balloon, eventually there's equilibrium when it's down here.
And it'll expand inside of the balloon, causing it to burst.
Because the higher up you go, there's less air molecules. So that means that there's less outside air pressure. But there's still the same amount of inside pressure from the helium. So that keeps expanding, trying to get out of the balloon because there's less pressure. Therefore, when there's not enough pressure, which is when there's just enough pressure for it to pop, which is why we can't touch the balloon, because we might weaken the rubber, and make it pop early.
Yeah. It's a lot simpler than it sounds. I promise.
Yes.
Yeah. The closer you get to leaving the atmosphere, the less pressure there is, which is what causes the change in the equilibrium.
And if we had a video, the balloon would get steadily bigger as it went higher.
So if you thought it was big when it was going off the ground,
It's bigger.
it's gonna get really big.
It's even bigger now.
Alright.
Thank you.
What time are we at? 10:42. You want to get that? You want to bring it up here? Danielle? Yeah. We're gonna do GL Robotics. He's doing Danielle. All right, can we get the camera back for a sec? There we are. Good. While we're on a roll with our sponsors, we'd like to thank GL Robotics.
They sell custom 3D printed items.
As well as 3D printers.
And robotic lawnmowers.
Pretty high quality stuff if you ask me. I
And
mean, look at this. Come on. That's pretty cool.
the fact that they took the time just to 3D print a rocket for our background. Thank you, GL Robotics. Alright, you can go.
All right, now we will be interviewing Danielle. I'll let Leland introduce her.
this is Danielle. Danielle, the sorry, the mission control director. She is the person who looks over everything at mission control, making sure that everything's working well. So I just explained it. What does the mission control director do?
I oversee the mission control team during preparation for the flight and throughout the entire flight as well. I ensure that everyone does their job as it needs to be done and help out if anything goes wrong. I also did the no-go sequence earlier to ensure the electronics and launch site were both prepared for launch, as well as counting down from 10 to 0, so we were all on the same timeline.
Why did you pick this decision? Pick this head of office?
I've been on the team for a few years. It's my 4th year currently. During all 3 prior years, I had mentors and leaders to be there for me and teach me anything I didn't know about. All I had to do was ask. So I wanted to be able to help younger people or people simply with less experience the same way my mentors have helped me and taught me over the years.
So, this is your senior year, right?
Yes.
So, is what you're learning now, are you going to take that into wherever you're going after this year?
I do believe I can take some of it. I don't particularly want to do anything space related, but simply being in a leadership position, learning communication skills, how to hold myself accountable and responsible for everything going on, I do think will pay off in the long run.
And so this is your senior year. What college are you going to?
I'm deciding between Troy and the University of South Alabama at the moment.
And what do you think you want to major in?
Primarily criminal justice. I'm considering dual majoring in criminal justice and business administration for a career in law enforcement.
All right, so don't mess with you when I break the law. Got it. All right, thanks, Danielle.
Thank you.
Let you guys know that we're real close to the burst altitude. It is going to be a little over 70,000 feet, and we can tell by the pressure of the data that we're getting. It's in a very low pressure environment, and so that means our balloon's going to expand and reach a burst, which is about where we predicted it. It is running a little bit north of what our flight predictor indicated, but that's not unusual. And so we will check in with the recovery team here in a minute, but we're going to take about a 5-minute break. We'll let you guys look at the flight data information, and then we'll report back in, and we should have a burst at that time.
Hair did not want to hair.
Negative 11.2 degrees Fahrenheit.
It's fine. All right, I think we're back from our break. Okay, yep, we're back. Cool. So, if you saw just now, if you're paying attention like you should be, you'd see on the Featherlight tracker that we topped out at about 70, yeah, we're about at 77,000 feet. We're expecting a burst pretty soon. We should be coming to a descent any minute now. We're just waiting from a confirmation from the launch team. Let's check out our GPS, see where that's at. There we go. All right, can we zoom out a little bit so we can see the whole? We can't zoom out? It's just, oh, there we go. Much better.
Definitely.
All right, so you can see that that's crossing state lines, right? Yeah, we crossed state lines near there.
Blakely.
Yeah, Mays Mill Road. That's about where they're at right now. Yeah. Can we check back in with our launch, with our recovery team? Can we do that? Okay, 1 minute. Cool.
Check back in with McKenna.
All right.
No, please. Have mercy.
How do you get clean in outer space?
How do you what now?
How do you get clean in outer space?
Ooh, wait, I know this one. You take a meteor shower.
You looked, didn't you?
No.
Let me get a new one. Don't look this time. Oh, we got a recovery team back.
Go get it. Hello.
Is this Landon?
Leland?
Landon. So, are you at the point where you think it's going to land now?
We actually I would say we have to go back west. We were a little bit too far east, and the weather, the balloon's changing because it has to follow the weather and winds. So we have to go back east, and the people believe the balloon is still rising. So
we're still rising?
Yeah. Last time I saw it, it was at 80,000 feet.
Oh.
Yeah, near 80,000.
We're about to break 80,000. Okay. Cool.
So, how long does it take for the balloon to fall after it bursts?
81,000 feet.
Landon?
Sorry.
Did you just say how long will it take to land after it breaks?
Yes.
So, the recovery team doesn't really know. It is going to take a lot faster though. It's going to take less time than when it was rising, because instead of it having to fight gravity, it's now going with gravity down.
Mm-hmm.
So we kind of are hoping it's not going to get damaged in the process, but we just don't really know.
It's
Mission
been a
Control.
while since we've checked in with our flight predictor.
Mission Control, can we see the flight prediction?
There we go. All right, you can see now, it's changed a little bit, I think.
Yes, because it says that it's going to burst at 7.
That yellow point right there is our descending, the spot where we hope it bursts, where we think it's going to. And
No, the
what's
blue is where it
the blue?
is. That's where it is now.
Oh,
That's where we got it.
okay.
Just run a little north.
Thank you, Landon.
It's just a little bit north of where we thought it was going to be. It's okay. So the blue spot is where we think it's going to land instead of the red spot, right?
Blue spot's an actual data point.
Oh.
He's tracking for us.
Okay, so that's an actual data point that they're tracking.
It's at the blue spot right now. Or it should be. As you can see, the balloon definitely went a bit more north than we expected. And higher.
Yeah. Why don't we check back in with the feather light and see how high it's gotten? Still rising. Wow.
Uh-oh.
So we're definitely reaching how high we thought we would go.
We're over-exceeding how high we thought it would go.
Yeah.
$76. We have confirmation that the balloon has burst.
Mm-hmm.
Yeah, it's descending.
Yes.
Yeah, it's descending now, for sure. Yay!
Well, that's a good thing.
Yeah.
Now we get to see what that gummy looks like.
Do you know
I
what
think we
our
should go
descent
back-
rate is?
I think we should. Definitely faster than 1,000 feet per minute.
Yeah.
I think we should go back over the experiments again.
Okay.
The
Yep.
I'll be there. Wait, where's my paper go? Oh. So in one capsule there's a triangle of gallium. And the reason why it's in a triangle
A pyramid.
a pyramid. 3D triangle. A pyramid of gallium, and the reason why it's in a pyramid is so that we can see if it melts and reforms. And as I said, gallium will stain your skin, it's non-toxic, and if it gets on a metal, that metal is easily breakable.
And we also have the gusher gummy. We were supposed to have an RCA student to come in and interview, but unfortunately, I guess it didn't work out. So we'll see how that goes. I think it's gonna burst, like we said.
And we have rubber bands, 3 rubber bands, one inside the capsule, another on the outside of the capsule wrapped around, and another stretched out on the outside of the entire experiment box.
We've got a marshmallow, which we think is going to expand because of all of the tiny little air bubbles in there. You know how it's really foamy when you bite into it. And we've got popcorn. Yeah.
Kernels, popcorn kernels.
Kernels, not popped.
Maybe
Well,
they'll come
maybe.
down popped.
I don't know. I don't think so.
I think they might.
That's just my hypothesis, though.
I think they might.
All right.
And we have the 3. Yeah, 3. Okay.
Okay. And I believe we have Mr. Greg here, who we're about to interview. Right? There we are. Okay. So this is a huge project. It's a giant undertaking. The workload is pretty massive. So what really inspired you to start this project?
It's actually something I've been wanting to do. I saw a couple of folks do this on YouTube. They never went into the detail that we did. By the way, you and Leland did an awesome job, and we're going to continue to do an awesome job. But I'm real proud of the students and the hard work. We actually formed a corporation, and we gave each of the students a title and a responsibility, and it was their job to make this happen, and they were able to pull it off, and it makes me real proud of you. You know, it's not all the time you get to see a group of students accomplish so much in such a small amount of time.
Yeah, this definitely was a pretty short time period for how big it is. So,
but I'll answer your question. So again, I happened to see this a couple of years ago, really, and it was kind of a bucket list thing. I thought it was super cool to go to space, and I wanted to make that happen. There were a lot of unknowns in developing this. And then at the time, our class, our robotics team really was involved in a robotics competition, and so we just didn't have a whole lot of time to pursue this. But this year we said we're going to do it, and so that's where we began. And sometimes we made it up as we went, right?
Yeah.
But we have a balloon burst. I'd like to see that data again.
Yeah, let's pull that up. About 64,000 feet.
Yeah, so we are coming down fast, but fortunately not too fast. And so we should be able to recover that pretty soon. Our gator bait recovery team is out there, and we're weaving them back and forth in a rural area of Georgia. And so we have to be careful not to get them on a path that doesn't even have a place for a car to go. And so we're trying to get them there, and based on what the balloon says we're doing. And there is the current location, if I'm reading that right. So it's pretty exciting. We're looking forward to getting the data. Landon was talking a little bit about some of the experiments that we had on there. I actually own GL Robotics, one of the sponsors, and we have a lot of plans for this program, and we're going to do a lot of specialized things. And one of the things we needed to understand was which 3D filaments perform best at these types of altitudes, pressure, and temperatures. And so we put a sample of PLA, ABS, PETG, ASA, we did some carbon fiber, we did some TPU filaments, and if you're into 3D printing, you know exactly what I'm talking about. And so we've sent all of those up to space, and when we get them back, we're going to do some testing on them, see which ones remain pliable, which ones maintain their shape, if there's any issues with that, which ones maintain their color, because they're looking at 100% UV. And then we'll get those results out to you guys, and so you can you'll know in case you want to do a project like this. And then as we look into the future, we're going to do more and more experiments, and we've got some pretty good long-term goals. We certainly want to put a servo up there and be able to move it so that we can release some objects when necessary, and do some other cool stuff. We did send a solar panel driven by an LED light. That would be an LED light driven by a solar panel, and up there, and we're gonna have video of it, and we want to see if it was able to maintain a charge, if the solar panel did not face the direction of the sun, if it turned off or not, all those kind of things, what kind of charge we have on the battery coming back to there. And so we got a lot of neat things that we're doing, but we're always interested in your ideas. So if you want to leave in the comments below some ideas for experiments in the future, then let us know, and we'll take those into consideration, definitely. We plan on doing this twice a year, as long as Emma and Leland are with me. And our next one, and we'll get more information, but it'll probably be somewhere around April, May timeframe. So be looking for that. And definitely, if you run into this, when it's not live, it's going to be on our YouTube channel, definitely subscribe, and you'll get notification when our next launch is. And besides that, we're going to be doing a lot of cool stuff in between.
Yeah. It looks like we're about 45,000 feet now.
All right.
Oh, look at that speed.
Yeah, it's following at 2,400. Yeah, that's probably about right. We'll know for sure, but
oh, we're at 34,000 now. Wow.
so
I guess it just updated.
yeah. All right. Well, that's interesting. I can't tell. We're zoomed in so close to the Earth. I can't really tell where they are in relation to our two major.
Yeah, can we blow it way back out so we can see the full path?
Addie, move out some more, please. That might be as far out as it goes. How's the GPS coordinates going? Can we look at that? Site for us because it is sparsely populated, and so we won't have any issues with traffic or anything like that. It may surprise a farmer, however. Should be fun.
Yeah, and even if they do land in a pond or marsh, the gator bait recovery vehicle is pretty well equipped to handle all that.
Do we have a GPS point update? Okay, we're just waiting on that any minute. Now, did you have any more questions for me?
Yeah, I did actually. So, what's one of the biggest challenges you faced trying to lead a group of pretty young people?
Yeah, we do have a younger team this year, and it's really, the challenges aren't any different than any of the other teams. It's just a matter of effectively communicating with the students, helping them grow. One of the reasons I do this is I try to get the students outside their comfort zone. And a lot of students are apprehensive about getting in front of a camera. And so you might know a little bit about that, but once you do it a couple of times, you get more and more comfortable. And it's all about becoming a leader, really. And we want our students to be leaders. We want them to have knowledge of the STEM disciplines. There's nothing that says that Christians can't be scientists, engineers, rocket scientists. I don't know if that narrative is out there still, but I can tell you over the last 10 years, me and a bunch of other mentors for Ridgecrest Christian School have proven that theory wrong. We have been very successful in our competitions, and we've been, when we're going to be successful today. And so that's, again, is what really makes me proud of you guys.
So next launch, around in the springtime, what would you do differently? What's one of the new things that we want to do?
Yeah, again, we wanted to see if we can get a servo to operate, and we're going to try to actuate it at a certain altitude. And so what we'll do is we'll create a separate circuit board that will have, we'll be able to measure the altitude, and then at a certain altitude it'll actually actuate the servo, and then the servo is going to release a door on a box, and then we're going to release something in outer space, something non-hazardous, obviously, and just to see if we can make it work. And that's something that we can build on moving forward. We also have a big goal of doing live video while we're up there, and working with some companies to help us do that, and that's another goal. I don't know if we'll get to that one in the spring. And then,
someday.
And then next year, announcement, next year, we're actually going to start a rocket competition. We're going to build rockets and compete with an organization all over the country.
Wow.
And so we're going to add that to our program. So a lot of exciting things coming on.
That's news to me for sure. It's exciting.
You heard it here first. Oh, it looks like our altitude. Is that pressure versus, okay, yeah, all right. I don't know if we've gotten an update lately.
Guess not. It's been at 37,000 for a little bit now.
Yeah, we may have run out of battery on that feather light.
Oh.
I don't know if we can tell that or not, but that's why I'm interested in the GPS coordinates. Oh, it says we have almost 4 volts of battery. So, so the feather light uses a system. Really, it's using a system called Helium, and Helium is based on LoRaWAN technology. That's spelled LoRaWAN. And LoRaWAN is a network of rooftop, not satellites, but antennas that give the data and pick up and receive data. And you can actually use it for cell service. You can use it for Internet of Things. It has a lot of capabilities, and you're starting to see more and more of these. And what's neat about it is that it's more of a private type system rather than a big network like Verizon or someone would use. And so once we get below an altitude, we will, it's possible, especially out here in a remote area, that we will lose the featherlight tracker. And that's why we have the GPS spot trace on there to pick up once we get below where the wide area network is.
Looks like we're at 25,000 feet now.
Okay. So just depending on the telemetry direction that the package is facing, can determine whether we get a data point or not. So it's super exciting. I think we need to check in with our recovery team, see how close they are.
Yeah.
I don't know if we got a point of where they are or not. We'll see. They'll come in here yelling, no, don't ask that. Okay. Oh. So they might be where there is no cell service. Yeah, this is a very remote area. A lot of farms, a lot of cotton and peanuts are grown in this area. That's kind of an interesting. Zoom back out. Zoom back out. A little more.
Hopefully it lands somewhere like that.
Yeah, that would be convenient for it to land right by the road, huh? But you can see it is a farm area because of the circle. That's actually a center pivot. So it's a giant sprinkler system that rotates on tracks and helps keep that watered. And that's why that field is shaped that way. You'll see a lot of those here and in the Midwest if you fly over them. It's really interesting. So we should be getting a GPS spot package. So Emma, what do you know about robotic lawnmowers?
Not as much as I'd like to. Why don't you tell me about that?
Well, we sell robotic lawnmowers, and it's really interesting. You know, they will actually go out on their own, mow the lawn. In fact, I'm mowing my lawn right now, and it's just a neat way to get a chore done that most people don't like to do. It's doesn't have any emissions, doesn't require gas, doesn't require oil changes or anything like that.
It's like an outdoor Roomba then, right?
It is, yep. And now they have a new system that they've perfected is probably the right way, where it uses a RTK, real-time kinetics system antenna, and so we can put an antenna in a spot and let the robotic mower connect to the antenna, use GPS satellites, and it'll actually mow in straight lines back and forth, or we can program it to mow in any kind of pattern, really. And it's pretty cool.
Very cool.
Really is.
Geo robotics.
Yeah, yes, definitely. Oh, we got us a data point.
20,000 feet.
Switch back to the GPS.
Looks like we're slowing down.
Are we slowing down? That's good. That means we're not dropping a missile. And hey, I don't, oh, there it is, okay. Yeah. We're at 45. Zoom out for me. And hey, let me see exactly where we are in the world. Oh, we're near Arlington, okay. Yeah, so it's gone a little bit further than we thought it would, but based on the Ascent rate, I'm not surprised. I think we might not have gotten all the 80 cubic feet of helium in the balloon. It's our first time. We were all concerned that we were putting too much in it. And so that made our ascent rate a little bit slower, which is kind of a neat thing. That's why it went a lot higher than we had predicted too. So we're gonna get some awesome shots of the edge of space and the curvature of the Earth. And we'll be sharing those when we get all that information back. We'll put that at the end of the video here and share that information with you, as well as the results from our experiments. We'll do some short little blurbs of what our results are found. So again, that's another reason to subscribe to the channel so that you can get that information.
You think we'll get that picture of all of us on the edge of space?
I do think that. I don't know how well we'll be able to see y'all, but as far as your faces, yeah. We don't know, but it's a work in progress, and if we need to put it somewhere different next time, we will. But
we'll get that
there was
picture.
a lot of moving parts in this one.
For sure.
Definitely. We're moving right along here. At 20,000 feet, you might actually be able to see the parachute. It sure would be interesting if anyone was in that area, if they could tell us if they saw it or not. That would be a lot of fun. That area is looking a little swampy, but we should miss that area because we're still pretty high up. Good. You got some questions for me?
Not really about, except for what you already discussed. Addie said that the pings are going to start stopping.
I can hear them giving our recovery team directions. I think in the future we should put this on the broadcast so you guys can hear. So obviously our balloon flies as a balloon flies, right? And our recovery team has to take the roads, and so they're zigzagging across trying to catch up with it. And of course the balloon's flying in a straight line, and it's pretty funny to listen to. So Leland, you ever been in space?
No.
No? Would you ever like to go?
That's a good question.
Yeah?
Because of all the training that you have to go through.
Yeah. I watched a video the other day. Really, they're selling high altitude balloon rides. They've created a special capsule, and they're going to put a big balloon on it, and they're going to take you up about 100,000 feet. And so you can say you've been to space or whatever. It cost $175,000, but I've got a birthday coming up. If you would like to gift that to me, I would certainly take you up on that. But I think it's cool. As long as it's secure, right? And I don't have to get out of the thing like we saw that guy do.
The Red Bull video?
Yeah, on that video where he jumped from, I guess he was about 100,000 feet.
I've heard that jumping from that high, you have to make sure that you're going to be spinning, but if you spin too fast, all the blood's going to be pulled away from your heart.
Yeah.
So you have to make sure that you control your spin speed.
Yeah, which I don't know how to do. We're at 11,000 feet. So we are really close to this. I don't know if we'll stay on the live stream for the whole thing. But we certainly are going to film it. We've got some film crews on Gator Bait. Did they talk about why we called it the recovery vehicle Gator Bait? That was funny. Yep.
That would be Landon.
Yeah. That's good. So close.
The
So
pings
close.
are going to be less and less frequent.
Huh?
The pings are going to be less and less frequent from
We
the feather
again,
light.
we may lose, the feather light.
But it's not the battery, it's the altitude.
Is it?
Mm-hmm.
Yeah. Okay. Yeah. And so we're going to rely on the GPS spot trace from here on out. Looks like it's going to land in a perfect location based on that information.
Not in a swamp.
Not in a swamp.
Or the Gulf of Mexico.
You know, we ran the predictor a bunch of times, and for fun, we ran it once when that hurricane came through. And obviously, we got a pretty wild path there. But sometimes, based on what the weather was doing, the package would go due south. Now, you know, where we're located here in Dothan, we're at only about, I don't know, 200 miles from Gulf of Mexico. And so that could have gotten pretty hairy pretty fast. And so I'm thankful to the Lord for this and really for everything. We're going to probably wind this up and then we'll give you an update once we receive the package. But I just do want to thank the kids for everything they did and really thank God for blessing us, giving us this equipment that we can use, and I'm thankful for Ridgecrest Christian and all the guys in the media, Steve and Broxton and David and Jared, who volunteered their time to help us. And that's just what being part of a community is about, and being part of a church. Church is not the building, it's the people. And I would encourage anyone out there that is struggling, which we all do, to reach out to us. We'll have some information at the end of this video with a QR code that you can scan and reach out to us, and we would be glad to contact you, tell you about the difference that Jesus has made in our lives, and how He is our Lord and Savior. And we also would just want to love on you. And so definitely reach out to us with any questions, and we will get with you. So I think we're going to end our broadcast here, and we will follow up with you as soon as possible. I'm going to let Emma come back in, and y'all can say bye to her.
Greg.
And
Switching seats, that's fine. All right, well, thank you all very much for watching. We appreciate your viewership. You have anything else to say?
Yes. Thank you, Mr. Greg.
Thank you, Mr. Greg.
Everybody cheer for Mr. Greg. They're so enthusiastic.
All right.
That concludes what I have to say. But I'm exhausted because I've been sitting